Hello students, welcome back to a new section of Real Numbers class 10. We have already understood two topics in the previous two lectures. In this session, we'll understand theorem 1.3 and some examples, questions related to it so that it becomes easy for you to understand basically. So let's start. They are saying that let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. Okay, let's understand this again by taking an example. So we are taking P as a prime number and P divides A square. Okay, let's take P as 7. Okay, and if P divides A square, we take as 49. Okay, 49 is the A square. So A will be, can you tell me? 7, because 7 sevens are 49. So A square will be 49. So they are saying if P divides A square, then P divides A as well. If we convert this in the form of example, so it means if 7 divides by 49, then 7 divides by 7 as well. And this is right, because 49 is divided by 7, we get the answer as 7, and 7 is divided by 7, we get the answer as 1. So where A is a positive integer, we took A as 7. 7 is a positive integer, right? So let us prove this, okay? This you won't get anything like this to solve in your examination, but this is just to make you understand it more briefly and so that it stucks in your mind and never bends, okay? So A is equals to P1, P2 till Pn, where P1, P2 till Pn are prime, not necessarily distinct. They are saying that all these P's are prime numbers. Therefore, A square, what they told that in the previous theorem, that if A square is divided by P, then A is also divided by P. Okay, so A is P1, P2 till P9. So A square will be square of P1, P2, P9. So they have written P1, P2 till Pn multiplied by P1, P2 by Pn. So what it becomes? P1 square, P2 square, dash, dash, dash till Pn square, right? Now, since A is equals to P1, P2 till Pn, P divides A, right? P is of course dividing by A. And this is the proof. This proof is based on a technique called proof by contradiction. Okay. Theorem 1.4. They are directly saying that root 2 is irrational. Okay. So let's see how do we know that if it is rational, if it is irrational, we don't know it. Let's check it out. So let us assume to the contrary that root 2 is rational. So for example, when you are arguing with anybody and you have to prove your point to themselves, don't say to them that, no, you are wrong, but say to them that assume that you are correct and give the explanation on their assumption. So when their assumption is wrong, we can prove that, no, your assumptions were wrong, so I am correct. Okay, this is the proper way to argue and keep your point valid, right? So let us assume to the contrary that root 2 is rational. We are assuming that it is rational. So we can find integers r and s which are not equal to 0 such that root 2 is equals to r by s. Okay, we know that rational numbers can always be written in the form of p by q, where p and q are any integers and q is not equal to 0. So they have taken r by s, it's one and the same thing. Now let's see that suppose r and s have a common factor other than 1. Then we divide by a common factor to get root 2. Now they are saying where a and b are co-prime. So b is equal to root. So what they have done is in this step, b root 2 is equal to a. They have just shifted this b to the left hand side near root 2. So this b is shifted here. So it becomes b root 2 is equal to a. Okay. Simple. Squaring on both the sides and rearranging, we get root 2 into root 2. You know what is it? Root 2 into root 2 is 2. And b square, b was already there, root 2 b was there. So b into b becomes b square, and on the right hand side it was a, and squaring that becomes a square. Therefore, 2 divides a square. So what they have done, now substituting for a, we get 2b square is equals to 4c square. let's see what they have done here. 2 is dividing by a square, right? So in this step, 2b square becomes 4c square. That is, b square is equal to 2c square. Now what they've done is they have divided 2 by left hand side and right hand side. So 2 divided by 2 both gets cancelled and it becomes b square, and 4 divided by 2 gives 2. So it becomes 2c square. Therefore, a and b have at least 2 as a common factor, right? Because 2 is of course there near 2c square, so 2 is at least one common factor. But this contradicts the fact that a and b have no common factor other than 1, because of our incorrect assumption that root 2 is irrational. Now you got the point. If it was rational, then root 2 wouldn't have, like, it was rational, so root 2 came as a has common factor 2. Now, since it is not that case, so now root 2 becomes irrational. Means our assumption was wrong. Now they are saying that show that 5 minus root 3 is irrational. Let's see. Let us assume to the contrary again that 5 minus root 3 is rational. Now we can find co-prime a and b where b is not equal to 0, such that 5 minus root 3 is a by b. Because it's rational, it can be written in this form. Now, rearranging the equation, we get what they have done is, see carefully. Here it was 5 minus root 3 is equal to a by b. Now what they have done is, it was 5 minus root 3, right? So root 3 came on the other side and a by b came on the other side, and we changed the signs, okay? Now in this, for this step, they have taken out the LCM, and in which denominator was a by b, b was the denominator. So LCM comes out to be 5b minus a by b, right? Since a and b are integer, we get 5 minus a by b is rational. So root 3 is rational. Now see what they have done. Root 3. Here it was root 3 and 5 minus a by b. If a by b is rational, then if you are subtracting 5 from it, then it will also be rational, right? So they are saying that root 3 is rational. Okay. Now is the suspense of the story, like climax of the story. But this contradicts the fact that root 2 is irrational because of our incorrect assumption that 5 minus root 3 is rational. Okay. Now in the next session, we'll understand decimal expansion. Till then, you just have to practice these questions and the theories that we have done in all these 3 sections. Keep that in mind and try to solve the questions from the NCERT. So this was all for today, and keep practicing.